We spend thousands of hours in front of screens. Whether we're programming, editing video, or doing office work, we still rely almost entirely on our hands. Those thousands of repetitive movements and clicks are a huge strain, which for many of us ends in chronic pain and wrist problems. But for a part of society, a traditional keyboard and mouse are an insurmountable barrier. Amputees, people missing an upper limb, or those struggling with partial arm paralysis are often excluded from the digital workspace. That's why I created FooTrack. It's a fully programmable, foot-operated device that not only revolutionizes the daily workflow of professionals, but above all, restores digital independence to those who need it most. Let's see how it works in practice. On the main screen, you can see my desktop. In one window, my hands. In the other, my feet on the FooTrack. After turning on the power, the script sending data from the device launches automatically. I have two icons on my desktop. One turns the track into a mouse, and the other into a gamepad. Clicking the first one launches the script and an info window with, among other things, the set cursor sensitivity level. I put my feet on the FooTrack. Its surface is soft and comfortable. Right foot on the TrackPoint, the other on the buttons, which have synthetic covers for better tactile feedback. If, due to paralysis or a missing hand, you only have one arm available, FooTrack takes over the functions of the missing limb. You can navigate with the mouse while your feet press modifier keys, shortcuts, or handle screen scrolling. FooTrack adapts to you, giving you full control and speed of work regardless of your physical limitations. That's why, when looking for the perfect foot mechanism, I reached for a solution used in professional business equipment, TrackPoint technology. A TrackPoint is an isometric device. What does that mean in practice? It means it physically barely moves at all. It reacts not to movement, but to the pressure force itself. The harder you press, the faster the cursor moves, or the timeline scrolls. And I brought this exact engineering under the desk, creating FooTrack. Thanks to this, you don't have to swing your whole leg around or make wide, tiring ankle movements. A subtle micro pressure of the foot is enough to take full control. For professionals, it saves energy and time. And for people with disabilities or arm paralysis, it's a mechanic that doesn't require physical strength to precisely manage the entire computer. Minimal effort, maximum accuracy. In FooTrack, we're not reinventing the wheel, but cleverly utilizing mechanics you already know perfectly well. Under the foot, I placed three main buttons, which by default correspond exactly to what you have under your hand: left, right, and middle mouse clicks. This works phenomenally, for example, when browsing the web or long lines of code. Just click the middle button with your foot, exactly like pressing the scroll wheel on a traditional mouse. From that moment on, a slight upward or downward tilt of your foot smoothly scrolls the screen's content, and you precisely control the scrolling speed with the pressure. Of course, this is just the starting point. FooTrack is fully customizable. Picture this: you're browsing the internet, reading an article, or scrolling through social media, and your hands are completely full. You can happily eat potato chips, hold a slice of pizza, and wash it down with a Coke. Or, like me while shooting this take, just drink water, and the screen still scrolls down smoothly at the dictate of your foot. Zero greasy marks on your mouse, zero putting your food down to scroll the text, just pure relaxation. For many people with mobility disabilities, struggling with partial arm paralysis, amputees, or those suffering from chronic wrist conditions, a traditional keyboard and mouse are a huge barrier that very often excludes them from the digital job market. This is exactly where FooTrack shows its greatest power, becoming something more than just a controller. It becomes a prosthesis of functionality. By transferring key navigation tasks, shortcuts, and clicks to the feet, this device instantly restores full operability to people who only have one fully functional hand available. This is no longer just a matter of convenience. It's a matter of regaining independence and real employability. But FooTrack isn't just about work and web browsing. Hidden under the second icon in the dedicated app is a completely new mode that turns the device into a fully fledged gamepad. When I click it, my custom background script automatically kills the previous process and instantly launches a new one, making the hardware immediately ready for action. You're probably wondering why I even went through the trouble of emulating an Xbox controller instead of just programming FooTrack as a second mouse. The answer lies in the operating system architecture and how video games treat pointing devices. If FooTrack identified itself as another mouse, the system would simply merge the signals from both devices into one shared cursor. Imagine that in practice. You're trying to aim precisely with your hand, and at the same time you're moving your foot to walk. As a result, the signals start fighting each other, and the crosshair jumps chaotically all over the screen because game engines can't assign different axes to mouse A and mouse B. So I had to completely separate this signal. My foot movement movements on the TrackPoint precisely replicate the tilt of an analog stick, and the device's 3 buttons perfectly correspond to the assigned actions on the controller. I ran an analog stick circularity test, and the result is a flat 0% error rate, which is simply a perfect score, guaranteeing full precision. If you're worried about delays in games, let me put your mind at ease right away. Wi-Fi communication gives me a much lower delay and lower input lag here than a standard Bluetooth connection. And to test it in combat, let's fire up Cyberpunk. The biggest challenge turned out to be tricking the operating system itself into recognizing this wireless device as a native Xbox controller. After all, we have Wi-Fi communication here, which meant the need to integrate a virtual driver on the PC side that translates network signals into virtual controller movements in real time. The second wall I hit was the physics of the TrackPoint itself. Because it's an incredibly sensitive pressure force sensor, the raw data from the microcontroller was initially full of noise and micro vibrations, which resulted in the character drifting on its own in games. I had to write my own filtering algorithms, sensitivity curves, dead zones, and an auto-calibration system from scratch to prevent drifting. Add to that a heavy optimization of the network transmission, where I had to switch to lightning-fast UDP packets so as not to lose a single fraction of a second of reaction time. That was dozens of hours of tedious testing, tweaking, and recompiling the code until the moment the virtual analog stick finally started reacting absolutely perfectly and without delay. But it was worth it, which I'll prove to you in a second, because I see the game just loaded, so let's get to the action. I moved all the character movement from the keyboard straight to the FooTrack, while the mouse in my right hand handles aiming and looking around. My left hand is completely free. I'm currently running around Night City, playing a very dynamic title using only one hand and one foot. Because the TrackPoint reacts to the pressure force itself, moving the character becomes incredibly intuitive. This, by the way, opens up amazing possibilities for the world of virtual reality. Theoretically, transferring locomotion from artificially tilting your thumb on a controller straight to the physical work of our feet and legs could potentially solve the problem of motion sickness and vestibular mismatch that so often ruins the fun in VR. It's a huge potential that I will definitely be testing rigorously in the near future. A gentle press of the foot is precise, slow sneaking, and a firmer press is a smooth transition into a full sprint. On top of that, there are the action buttons, one of which I assigned to jumping. Executing a jump in-game by physically stomping your foot on a floor button gives such natural feedback that it's downright addictive. I have to confess, though, that I got used to using my whole body to control the game in a flash. Engaging hands for precise aiming and feet for moving not only works exceptionally well, but it just brings me pure, immense joy, taking immersion to a whole new, much more physical level. Under my left foot, aside from the directional sensor itself, I have at my disposal the previously mentioned 3 fully customizable buttons. In Cyberpunk, I assigned them to the most important actions: jumping, sprinting, and crouching. And I have to tell you, it performs just brilliantly. When I'm in the middle of an intense firefight, physically stomping my foot to jump over an obstacle, trigger a fast run, or quickly slide behind cover is not only incredibly intuitive, but also gives phenomenal physical satisfaction. My single freehand, used for gaming, doesn't have to look for extra keys on the keyboard at all, because my left leg flawlessly takes over absolutely all the character's acrobatics, reacting to the situation in fractions of a second. By turning FooTrack into a virtual gamepad, I took advantage of the fact that modern productions perfectly support simultaneous reading from different devices, or so-called mixed input. The game now treats my foot as the left analog stick of a controller, giving me fully smooth analog control over the character's movement, while allowing my right hand to use a real mouse for lightning-fast aiming. It's the only solution that allows these two worlds to be seamlessly combined in one game without clashing. On the one hand, it allows professionals to regain valuable time, work more comfortably, and protect their wrists from strain. On the other, it becomes the key to digital independence for people with mobility limitations, restoring their full freedom to work. And after hours, it turns into a precise wireless gamepad that engages the whole body and takes gaming immersion to a completely new level. Oh wow, this ride matches my gun perfectly.